Suppose that a sample space is 1, 2, 3, 4, 5 till 10, and the outcomes are equally likely. Equally likely, it means that the probability of choosing 1 is the same as the probability of choosing 2. Compute the probability of the event E, a number is divisible by 3. Which of these divisible by 3? 3, 6, and 9. So it's a 3 number out of, so the answer is 3 out of 10. Find the probability of getting 2 tail when 3 fair coins are tossed. You can use another method of solving this one. These are mutually exclusive. The probability of choosing head not the same, it will not intersect with the probability of choosing tail. So in this one, I can use a simple thing. What's the probability of choosing tail for the first trial? 1 out of, and in the second one, and in the third one, not to choosing tail, 1 out of 2. So it's going to be 1 out of 8. No. This is in case of 3 consecutive tail. So we are going to go back to the sample space. We did it here. It says how many times choose what, head or tail? At least 2 tails, right? So it will be 2 or at least 2 or 3, right? So 1, 2, 3, 4, and 5. So the answer is 4. This is H. No. So it's 4 out of 8. And 4 out of 8 is equal 1 out of 2, right? Yes?
It's just find the probability of getting 2 tails, not at least 2 tails. So it's a 0 rate. So tails.
So let's go back. I said wallahi at least. It's okay, no problem. So it's gonna be 1, 2, and 3. So the answer 3 out of 8. So generally, if it say at least 2, it's gonna be half, but only 2 tails is gonna be 3 out of 8. Now for number 11, given that probability of A and probability of B, and this is the intersection, we said that yesterday that the probability of intersection is equal. Probability of A plus probability of B minus the probability of the union. And the probability of the union is equal probability of A plus probability of B minus the intersection. So if the intersection at the left, the union is at the right. If the union at the right, at the left, the intersection at the right. I want to find the union. So I'm going to add 0.32 plus 0.51 minus 0.15, which is equal 0.68. For number 12, I'm going to add 0.44 plus 0.5 minus the intersection with 0.77. The answer is 0.17. Now, something called mutually exclusive. Mutually exclusive means that there is no intersection between A and B. Probability of A is 0.22, probability of B is 0.25. And the union, in case of mutually exclusive, it means that A intersect B is equal to what? To 0. So the union in this case is equal probability of A plus probability of, which is equal 0.22 plus 0.25, which is 0.47. The second one says that A and B are mutually exclusive and they want to find the intersection. Directly, it's what? 0, because the mutually exclusive, the intersection is 0. Now, probability of A is 0.66 and the union is 1.07 and the intersection is 0.26. How I can find the probability of B? We should write the rule first. Probability of A union B is equal probability of A plus probability of B minus the probability of the intersection. But what if I wrote the union first and the intersection? It doesn't matter, it's the same. So probability of A union B is 1.07. Probability of A is 0.66. Probability of B, I don't know. This is the one I'm looking for. Minus 0.20. Now, what is 0.66 minus 0.26? 0.4. So 0.4 plus the probability of B is equal 1.07. So 0.4 move to the other side. 0.7 minus 0.4, which is 0.67, equal the probability of B. So the answer is C. Two six-sided dice, what is the probability that the sum of the two numbers on the dice will be greater than 10? To be greater than 10, it means that the first dice stand or appears 6, and the second one 5. 5 and 6 and... Why I'm not going to take 5 and 5? Because 5 and 5 is 10, and he says greater than 10. So it's a 3 out of, which is 1 out of 12. Now, a bag contains 6 red marbles, 4 blue, and 1 green. So what is the total? 11. What is the probability of choosing a marble that is red or green? So I'm going to write the probability of red plus the probability of green. The probability of red is and green. So it's going to be 7 over 11. For number 18, give the probability that a rolled die will show 4 or 5. 4 or 5 is 2 faces. To what? Out of 6 faces. So it's 2 out of 6, which is 1 out of 3. Number 19, 2 6-sides rolled. Rolled 2 6-sides mean the outcomes out of 36. What the probability that the sum is odd and the number on one of the dice is 3? So let's go back to the net that we draw it. Now, 3 is one of the faces, right? So 3 and 1, the sum is 4. But 3 and 2, the sum is 5. So here's 1. 3 and 3, sum is 6. 3 and 4, sum is 7. 3 and 5, sum is 8. 3 and 6 is 9. So I have 3. Now what about this 3? 3 and 1, sum is 4. But 3 and 2, sum is 5. 3 and 4, 3 and... So 1, 2, 3, 4, 5, and 6. So supposed to be 6 out of 36, which is 1 out of 6. For number 20, a spinner has region numbers from 1 to 15. What is the probability that the spinner will stop on an even or multiples of 3? Let's write what are the even. Even are 2, 4, 6, 8, 10, 12, and multiples of 3. 3, 6, 9, and 12. And from the common, we are taking only 1. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. So it's going to be 10 out of 15 divided by 5, which is 2 out of 3. So the answer is 8. For number 21, a bag contains 21 marbles. 6 are blue, 6 are green, and 1 marble drawing from the bag. 6 and 6 is 12. 12 out of 21 is 9, right? 12 out of 21 is 9. So the number of, I don't know what is the third color, but the number of the rest are 9 different colors. 1 marble is drawing. What is the probability that the marble is not blue? The marble not blue is 1 minus the probability of the blue. And the probability of the blue is 6 out of 21. So 1 minus 6 out of 21 is going to be 15 out of, and 15 out of 21, if you wanted to divide it up and down by 3, is going to be 5 over 7. For the last one, find the probability of having 4 girls, a 4-child family. What's the probability of choosing, or inshallah, يعني, having a girl at the first birth? 1 out of 2, because it's a boy or girl. The second one, 1 out of. Third one, fourth one. So 1 out of 2 times 1 out of 2 multiply, it's 1 out of 16. So the answer is